Righto, science students, we're going to discuss voltage and current in parallel circuits. So let's get to it. Now, in a series circuit, we stated the current is constant throughout the circuit. Well, in a parallel circuit, current is different across different resistors. Or different for different resistors. Different for different resistors. Now, let me explain why that is. Let's say that we have these two resistors in parallel, and this one's a 5 ohm resistor, and this one is a 10 ohm resistor. Well, charge is going to come through the wires and get to this junction and say, okay, I've got two choices. I can go down through this 5 ohm resistor, or I can go through this 10 ohm resistor. Now, much like human beings, charge likes to take the path of least resistance. So that means most of the charge will go through the 5 ohm resistor. Some will still go through the 10 ohm resistor, but the 5 ohm resistor will get more, so it's going to get more current. And the 10 ohm resistor will get less current. So that's why current is different in different parts of a parallel circuit. So what do you think happens with voltage? Well, you guessed it, voltage is constant across all resistors. Now, imagine that we had, say, a 100 volt power supply here. Now that means that this 5 ohm resistor will get 100 volts, and the 10 ohm resistor also gets 100 volts. So even though they've got different resistance, they both get the full voltage, and they don't even have to share it. They get the full voltage each, which is very interesting. It's difficult to explain quickly why that is, but remember that voltage is the amount of energy per coulomb of charge. So this charge is flowing up through this way with 100 joules per coulomb. And whether it goes through the 5 ohm resistor or the 10 ohm resistor, it's going to be carrying that amount of energy. So each coulomb of charge is bringing 100 joules of energy. So each resistor is going to get all the energy that's available from the power supply. So what we should note here is that things are switched around from series circuits where current was constant, it's voltage that's constant, and in a series circuit where voltage was different across different resistors, it's the current which is different across different resistors. So let's look at this example, not this one, but this one. And in this, we're going to calculate these things. Voltage. I'll write that a bit more neatly. Voltage across each resistor. And current across each resistor. Or the current through each resistor, really. Okay, so this is what we want to do. Right, so the 10 ohm resistor and the 25 ohm resistor. Well, this is going to be easy. I just told you that each resistor gets all of the available voltage. So the voltage across this guy is 9 volts. And it's the same for the 25 ohm resistor. They each get 9 volts when they're in parallel like this. Okay, so let's move along to the current. So for the 10 ohm resistor, we're just going to use Ohm's law again, which says that V equals I R. So that means that the current, I, is equal to voltage over resistance. So we know the voltage across this 10 ohm resistor is 9 volts, and the resistance of that resistor is 10 ohms. If we put that into the calculator, we're going to get 0.9 amps for our current across the 10 ohm resistor. Alright, after seeing that, you might feel confident enough to pause the video and see if you can get the current across the 25 ohm resistor. Then I'll have a go at it. Okay, so for the 25 ohm resistor, current is equal to voltage, 9 volts, over 25. 9 over 25 gives 0.36. Okay, so that's the current through that resistor. And we can see that the current through the 10 ohm resistor, the path of least resistance, is getting more flow, getting more current through the 10 ohm resistor, 0.9 compared to 0.36 amps through the higher resistance, 25 ohm resistor. Now just a quick one, the total current here is the sum of all the currents of all the different resistors that are involved. So in this instance, total current is going to be those two added up. So that is 1.26, I believe, amps. What that means is that if you were to measure the current here through the 10 ohm resistor, you're going to get 0.9 amps. If you measure it through the 25 ohm resistor, you're going to get 0.36 amps. But anywhere else in the circuit, like say here, this spot right here, that's going to be the total current, 1.26. Or if you did it over here, also 1.26 amps. So we still have a total current through the circuit. It's just that different resistors or resistors of different resistance will have different amounts of current flowing through them. And that's how you do it. So go ahead and have a look at the description for the video and try some of these voltage and current questions for parallel circuits.